In 2022, a couple in Jackson County, Oregon was ordered to tear out their heater. They had done everything right. They owned 18.7 acres of legal rural land. They had built a small permitted home on that land with full county approval. They had hired a professional engineer to design their wood heater. They had paid for independent third-party emissions testing. The test measured their particulate output at 0.12 grams per hour. The Environmental Protection Agency limit for certified wood stoves is 2.5 grams per hour. Their heater emitted less than 1/20th of what the federal government considers acceptable. During a winter inversion event in 2022, when cold air pressed down on the valley and trapped smoke from dozens of conventional wood stoves, a neighbor filed an air quality complaint. The county fire marshal inspected their property and issued a removal order. The couple appealed the decision. They brought their engineering documents. They demonstrated on paper and in person that their heater was the cleanest wood-burning device in the entire valley. The hearing officer's response, on the record, was this: compliance is determined by listing status and parcel size, not post hoc emission measurements. Read that sentence again. The law did not care whether the heater actually worked. The law did not care whether it actually polluted less than every other wood stove in the county. The law cared whether it had the correct sticker on its side. It did not. Not because it had failed any test, but because no testing category exists for the type of device they had built. Underwriters Laboratories, the private testing body that certifies almost every heating appliance sold in the United States, has never written a standard for site-built masonry heaters of this type. There is no sticker available. There is no application to fill out. The certification does not exist. The couple dismantled their heater at a cost of $4,200. To legally heat their home with wood that winter, they installed a $9,800 EPA certified gasification boiler, a more complicated machine. A machine with electronic controls, forced air fans, pressure sensors, and annual service contracts. A machine that burns more wood per hour than the heater they were forced to destroy. A machine whose emissions, by the manufacturer's own testing data, exceed what their original heater produced. The device they had to tear out was called a rocket mass heater. And this is the story of how a Welsh ecologist designed it in the 1970s to save the lungs of Guatemalan women. How its physics produce combustion so complete that the smoke itself becomes fuel. How it costs $300 to $700 in materials to build a unit that will radiate heat for 48 hours on a single armful of firewood. And how the permit system in the United States, built around manufacturer certifications rather than actual performance, has made the cleanest wood-burning technology in the world functionally illegal to install in most American counties. The year is 1976, Guatemala. A young applied ecologist from Wales named Ianto Evans is working with highland communities studying a public health crisis that has killed women and children. Across the developing world for centuries, traditional cooking fires. In most of rural Guatemala at that time, families cooked over open 3-stone hearths, 3 equally sized rocks supporting a clay pot over a wood fire. The fires burned throughout the day inside unventilated kitchens. Thick smoke filled the homes. Women developed chronic lung disease by their 40s. Children suffered asthma, pneumonia, and eye damage at extraordinary rates. The World Health Organization would later estimate that household air pollution from cooking fires killed millions of people globally every year, most of them women and young children, and the fires themselves were brutally inefficient. A typical 3-stone cooking fire loses 90% or more of its thermal energy to the open air around the pot. Most of the heat never reaches the food. Families spent half their daylight hours gathering firewood just to prepare 2 meals, stripping the surrounding forest year after year. Evans had trained as an architect in Wales in the 1960s. He had studied traditional building methods across the British Isles and developed an obsession with the physics of combustion and heat transfer. Working with the newly formed Aprovecho Research Institute in Oregon, he began redesigning the humble cooking stove from first principles. Here is what Evans understood that almost nobody else in household heating had applied. Wood is an excellent fuel, but wood almost never burns completely in ordinary fires. In an open flame, most of the wood's potential energy leaves the fire as unburned hydrocarbons. Creosote, soot, volatile gases, smoke. That visible smoke rising from any fireplace or wood stove is not waste. It is fuel you already paid for, floating away unused. The dark color of smoke is literally unburned carbon. The chemical haze above the flames is volatile organic compounds that contain enormous amounts of energy. An ordinary fire wastes all of it. If you could force that smoke to burn before it escaped, you would extract dramatically more heat from the same amount of wood. And the pollutants, which are the unburned fuel, would disappear as a direct consequence. Clean combustion is not a separate goal from fuel efficiency. They are the same physics. Evans designed the Lorena Cook stove, a small masonry unit built from sand and clay with an enclosed combustion chamber, a small fuel opening, and a precisely sized flue. The enclosed geometry forced the hot gases from the wood through a restricted path where they mixed with fresh oxygen at high temperature and combusted more completely than in any open fire. The Lorena stove used a fraction of the wood of the three-stone fire, produced a fraction of the smoke, and directed almost all of its heat into the cooking surface. It became the first successful self-help cook stove design widely adopted across Central America. Back in Oregon in the late 1970s, Evans turned his attention from saving Guatemalan lungs to heating Pacific Northwest homes. The question was simple. If wood could be burned almost completely in a small cooking stove, could the same principle be scaled up to heat an entire house? And could the heat be stored in a way that did not require constant feeding of the fire? He drew on two traditions. The first was the rocket stove principle, an insulated combustion chamber combined with an insulated vertical chimney called a heat riser. Here is why the geometry matters. When you insulate the combustion zone and the riser tube that rises directly above it, the hot gases accelerate rapidly as they climb. Rising gases create a powerful updraft. That updraft pulls fresh oxygen into the combustion chamber at exactly the velocity needed to mix violently with the wood and the gases the wood releases. Inside the insulated riser, temperatures climb past 1,000 degrees Celsius, almost 1,100 degrees Fahrenheit. At those temperatures, in that oxygen-rich vortex, not just the wood burns, the smoke burns, the creosote burns, the volatile organic compounds burn. Combustion completes itself in a single violent event inside the riser. What exits the top of the heat riser is almost pure carbon dioxide and water vapor. Not smoke, not pollution. Combustion byproducts at the theoretical limit of clean burning. This is why rocket mass heaters, when properly built and operated, have been independently measured at 0.1 to 0.2 grams per hour of particulate matter. 20 times cleaner than the federal EPA certification limit of 2.5 grams per hour for the best commercial wood stoves. You can stand next to the chimney of a running rocket mass heater and see essentially nothing coming out, only clear air shimmering from the heat. The emissions are not hidden or disguised. They are genuinely almost absent because the combustion is so complete that there is nothing visible left to emit. The second tradition Evans drew on was the masonry heater, Finnish and Russian stoves built from tons of stone and brick. Structures that absorb the heat from a short intense fire and release that heat slowly over the next 12 to 24 hours through radiation from their mass. No constant feeding required. You burn a small hot fire once or twice a day, and the thermal mass keeps the home warm around the clock. Evans then combined these two traditions into a single remarkable design. He took the rocket stove combustion chamber, oriented it horizontally so it could be fed from above, and ran the exhaust gases through a long curving flue embedded inside a massive bench or bed made of cob. A traditional mixture of clay, sand, and straw. The hot combustion gases give up their heat to the mass as they wind through it. By the time the gases reach the outdoor chimney, they have cooled dramatically. The mass keeps radiating warmth into the living space for up to 48 hours after the fire has gone out. He called it a rocket mass heater. In 2006, he published the definitive book on the design with his collaborator Leslie Jackson. Within a decade, thousands had been built by homesteaders, off-grid communities, and natural builders across North America, Europe, and beyond. The efficiency numbers tell you everything you need to know about why the heating industry has no interest in seeing this technology approved. A typical open fireplace operates at roughly 10 to 15% thermal efficiency. Most of the heat goes up the chimney. An EPA-certified modern wood stove might achieve 60 to 70% efficiency on manufacturer specifications, though real-world performance is usually lower because homeowners rarely operate stoves at laboratory test conditions. A well-built rocket mass heater routinely achieves 85 to 90% thermal efficiency. For every pound of wood you burn, roughly 90% of the available heat energy ends up in your home, rather than escaping into the sky. This translates directly to fuel consumption. A homeowner using a conventional wood stove in a cold climate might burn 3 to 5 cords of firewood per winter. A cord is roughly 3.6 cubic meters of tightly stacked wood. At current prices, that is $200 to $400 per cord. Hours upon hours of cutting, splitting, and stacking. A rocket mass heater in the same home, heating the same space through the same winter, typically burns half a cord to 1 cord, sometimes less. The wood does not have to be large split logs. The small diameter fuel that rocket mass heaters burn most efficiently is typically branches, saplings, and scrap wood. That firewood cutters usually discard, wrist-thick sticks, tree prunings, broken pallet boards, the kind of fuel you could gather from a single acre of woodland indefinitely without ever cutting a mature tree. Now here's the part where we need to be honest with each other. Building one of these is not easy. This is not a weekend project you knock out with a YouTube tutorial and a trip to the hardware store. The combustion geometry requires precise measurements. The ratio between the feed tube, the burn tunnel, and the heat riser determines whether you get clean, efficient combustion or a smoky mess. Getting those dimensions wrong by a few centimeters can ruin the draft and turn the whole thing into a dysfunctional smoke generator. Building the cob bench takes days of serious physical work. You mix clay, sand, and straw by foot or by shovel. You sculpt the bench by hand around the internal flue channels, ensuring no gaps where exhaust gases could leak into the living space. You wait for each layer to cure before adding the next. A full build, from excavating the floor to firing up the finished heater, typically takes 80 to 120 hours of focused labor. Many first-time builders make mistakes that have to be corrected before the unit runs properly. The materials cost $300 to $700 depending on what you can source locally. Fire brick for the combustion chamber, a steel barrel salvaged from a scrapyard, clay and sand from local deposits or bagged from a masonry supplier, stovepipe for the internal flue, metal chimney components for the exterior vent. None of it is exotic, but all of it has to fit together within tight tolerances. This is not a miracle product. It is a piece of careful, hand-built engineering that rewards dedication and punishes shortcuts. Evans himself has said that the first few you build will teach you what the next ones need to be. It is a craft. And despite all that honest complexity, the final economics are absurd. $300 to $700 in materials for a unit that will heat a small home for decades on a fraction of the wood, producing 20 times less particulate. Now compare that to a $9,800 EPA certified gasification boiler, roughly 14 times the material cost. A machine with a circulation pump that can fail, a control board that can fail, a primary fan and a secondary fan that can fail. Annual service costs of several $100s, an expected lifespan of 15 to 25 years before replacement. The math on which device is actually better for the environment, better for the homeowner, and better for the forest is not close. And yet the better device is the one that had to be torn out. This is where the structure of American building regulation comes into focus. Under Chapter 14 of the International Residential Code, adopted by 49 states, all heating equipment must be tested and labeled according to specific underwriters' laboratory standards. UL 1482 for solid fuel-burning stoves, UL 127 for factory-built fireplaces. Every commercial wood stove sold in the United States has been submitted to UL for a testing process that costs the manufacturer tens of thousands of dollars per individual model. Every design revision requires new testing. The cost is absorbed into retail pricing, which is why an EPA-certified wood stove costs what it costs. No site-built rocket mass heater has ever been UL certified. The testing regime is not designed for a device built by its user from local materials with designs that vary from one installation to the next. Getting an EPA letter of exemption, which is a different process, requires $4,000 to $5,000 in laboratory fees. Individual UL certification of a site-built design is practically impossible for a private homeowner to pursue. Masonry heaters in general are recognized in the International Residential Code under Section R.02. Handful of jurisdictions, most notably Portland, Oregon, after years of advocacy work by Ernie and Erica Wisner, and the team that worked directly with Ianto Evans, have adopted limited rocket mass heater guidelines as part of their alternative technology review processes. But for the vast majority of the United States, rocket mass heaters exist in the same legal gray zone as earth-sheltered homes, Verosement cisterns, and straw bale walls. Not explicitly banned, but without a certification category, functionally impossible to install legally in a permitted home with standard insurance coverage. The Jackson County case in 2022 made the consequences unmistakable. The homeowners had done everything that should have mattered: professional engineering, third-party testing, documented emissions below the legal limit. None of it mattered because the device lacked a certification sticker that literally does not exist to be obtained. Compliance is determined by listing status and parcel size, not post hoc emission measurements. Translated from bureaucratic English into plain English, that sentence means this: the system does not regulate pollution. The system regulates paperwork. Heater that pollutes 20 times less than an approved stove can be ordered removed. A heater that pollutes more than your neighbor's illegal one cannot, as long as it has the sticker. The regulation is not about outcomes. It is about standardized manufacturer certifications. And this is where the structure of the wood heating industry becomes relevant. The United States wood stove market generates over $1 billion in annual revenue. EPA-certified stoves retail from $2,000 to $8,000. Gasification boilers run $10,000 to $20,000. Chimney specialists, installation contractors, annual inspections, and replacement parts add thousands more over the lifetime of ownership. The entire business model depends on ongoing relationships with licensed trades. Rocket mass heater built from salvaged materials and local clay eliminates almost all of that. It has no moving parts, it has no electronics, it has no proprietary components. Once built, it burns a fraction of the fuel of any competing product. It produces cleaner exhaust than any competing product. It requires essentially no ongoing service beyond cleaning ash once a season. It outlives the homeowner who built it. It is, in every meaningful commercial sense, incompatible with the wood heating industry as currently organized. This is not a theory about villains in boardrooms suppressing innovation. This is the mechanical consequence of a regulatory system built around manufacturer certifications. When the rules require a UL sticker and the testing bodies have no category for your device is illegal by default. Not through active prohibition, through the simple absence of a pathway. The industry does not need to ban the rocket mass heater. The industry only needs to ensure that the certification frameworks continue to cover only the products the industry already sells. So, 4 decades after Ianto Evans designed the technology to help impoverished Guatemalan families breathe cleaner air while using less firewood, the same technology has become functionally illegal in most of rural America. Not because it fails any safety or emissions test, because it succeeds too completely, with materials too cheap, too local, and too unmonetizable to fit inside the certification system. The Guatemalan grandmother cooking over a cleaner fire. The Oregon couple ordered to tear out the cleanest heater in their valley. Same technology, same physics, different permit office. Ianto Evans is now in his 80s, living in Oregon. Ernie and Erica Wisner have built over 700 rocket mass heaters. Their book is still in print. The knowledge is preserved. It is just not welcome in your county. A couple in Jackson County heated their home that winter with a gasification boiler that cost twice as much in materials, burned more wood per hour, and polluted more per hour than the heater they were forced to destroy. The removal order cited no specific violation of any measurable emission standard, only the absence of a sticker that does not exist. The wood is still cut. The physics has not changed. The only thing standing between you and a heater that radiates warmth for 48 hours on a single armful of firewood is a permit office with no category for it and an insurance policy with no language for it.